Yeah, good evening. Please confirm I'm audible. Speaking, speaking. Hello guys, anybody online? Can you hear me? Please can you confirm you can hear me? Okay. There's some background noise which I don't know. I don't know. Yeah, I have. I guys not online. Or maybe thinking this 8 a.m. is even too early for us. I don't know. I don't know. 8 a.m. is even too early for us. I don't know. 8 a.m. is even too early for us. All right. So I believe you can hear me very well. Just confirm you can hear me very well, please. I believe you can hear me very well. Just confirm you can hear me very well. I don't actually have to. All right. Good. So let's just get started. still have a lot of things to cover, even though we just have today, Thursday, and Friday left. Right? We have a lot to cover. Right? We really do have a lot to cover. I mean, all right, but however ways this is going to work, we try as much as possible to make everything work together for our good. Like I said yesterday, right? Even if we don't get to finish everything, right? I'll also do premiering, right, to ensure that um, everything that is left is covered. So so you guys have nothing to worry about. I promise to give you everything you need, right? So I'll do just that. All right. So let's get started. All right, guys. Um, uh, so I would have wanted to use this material, but uh, or maybe I'll use another one. I don't know. Um, all right, let's go with this. This is also good. All right. So today we're starting with energy audit sizing, right? And this is the design aspect of the training, right? So yeah, let me just remove this so that I don't get distracted. All right, so this is the design aspect of the training. Okay, so this is where you really want to take time to understand. I mean, before anything else. Okay, so we're going to be starting with. Let me start with load audits. Um, Hello, do I want to I want to install solar system for my house or my business or my factory. So somebody calls and say, okay, this is what I want to do, right? Question is, how exactly are you going to start? All right. And this is where what we call the energy audit comes in, right? The first thing you have to do to carry out what we call energy audit. All right. This is the point where you go to the person's, I mean, you meet the client and you guys agree on the appliances that is going to be solar system and also um, for how long. All right. This is where you go to do a survey of the place where the installation is going to take place. All right, and you also find out what is the size and the capacity of the load that this client will be using. All right, this is the place where you do all of those. Okay, so um, the first thing you have to understand about energy audit are the different types of load that we have. All right, we have the resistive load. I think I've explained that before. We have the um, inductive load, and we also have what the capacity load, and you can have a combination of those loads. Right, you can have a combination of them. Right, resistive load are loads that give off heat. All right, and they don't necessarily draw so much of current. All right, they just draw sufficient current that is enough for them to work. All right, inductive load are the kind of load that have coil inside them. For example, a transformer, a motor, all right, a fan, refrigerator, air condition. All those are inductive load because what they have coils of wire inside them. All right, so you want to first understand the kind of load that um, the person, all right, wants to use. Let me bring up my notepad. Okay, so said that in carrying energy audits, right, you have to be able to determine the load that the person wants to use. Okay, you have to be able to determine the type of load that the person is using. All right, could be the resistive load. All right, could be the resistive load. All right, it could be an inductive. All right, it could be the capacitive, and it can be a combination of any of these three. All right, it can be a combination of any of these three. Oh, my camera is off. All right. Oh, my screen is not even visible. Sorry, guys. Just give me 1 minute. Let me fix the camera. I think. Okay, it's back now. All right. Oh yeah. Let's. All right. So you have the inductive. You see loads like electric cooker. You see iron, your TV. What else? Um, those kinds of and so on, right? As long as they don't have capacitors that is the major component or inductor being the major component inside, they are resistive loads. All right, they are resistive load. So you want to identify those, and after you have identified those, the next thing you want to find out is what is the capacity of the load. All right, what is the capacity of the individual load. All right, so you meet with your clients. All right, we're talking about energy audit here. All right, energy audit. So the client says, I have two TVs. All right, I also have a decoder. I also have what else, a blender that I want to use. All right, so let's just assume these are the appliances that the client wants to use. All right, and the next thing is to how many TV. All right, how many TV. So the person says, I have two TV, I have one decoder, I have two fans, I have one blender. All right, so the next thing, all right, the next thing to determine, the next thing to determine is the power of each of these or each of these appliances. All right, so you look at the back of the TV. All right, I've told us how to calculate power already. So you look at the back of the TV, you check the power rating, or you check the voltage and the current that is using at the back, and you find that the TV, all right, each of them is 90 watts. All right, so 90 watts, and then the decoder is around 20 watts. The fan, each of them is, let's say, 80 watts. The blender is around 100 watts. All right. So by the time you multiply the total this thing, you are going to arrive at this will give you 180. That's the total watts. This will give you 20 to give you 100. So if you add all of this together, 120 plus 180 plus 20, that's 200 plus 100, 300. Everything gives you what, 460 watts. All right. So
The client is simply telling you with this detail that the power consumption, the power that you will be consuming running this load is going to be around 460 watts. All right, 460 watts. So let's go back to our presentation. Let me set my camera. Give me just 1 minute. I think I'm audible again. Don't know. Let me check this one first. We can see him, right? Okay, cool. Sorry about that. Uh, so yeah, I was talking about how to get the name. I mean, sorry, the power consumption of the appliances, right? Um, I shared a screenshot to the group chat now, right? So if you want to know, for instance, this is a TV, all right? You can see this typical power. Uh, my screen is not showing yet. Okay, just hold on for it to load up. So I have a nameplate. Let me just open it so that's all right. My screen is visible now. All right. So look at this. Now this is a Samsung TV, right? Which has a typical power of 31 watts. All right. This might not be a TV. This might be a laptop. All right. But this tells you that the power consumption, right, of this device, whatever it is what 31 watts, and you can see the input. Oh, sorry, 64. watts. You can see the input of the to the device, which is around 240 volts, right? That's the voltage rating of this device, and the frequency, all right, at which it can run, all right. And then the input power, all right, that this device needs is around 64 watts, all right. So they tell you this will consume up to about 64 watts, right? So you can actually see the power consumption of any device if when you check the back of that, we are going to see this label, right? So you can either see the power consumption straight up, or you see this voltage here, all right? And you also have the power consumption, I mean the current consumption. They'll just write maybe like 0.5 amps, all right, somewhere around here. Okay, let me see if I can get anyone that looks like that. So you see something like that, all right, at any point, but I don't know if I can get anyone here. Check this. This is still in watts. Okay, but I can't find any now. But anyone you get, right? Anyone you get, if the this one is still in watts, this is in watt also. So you just have to multiply the current. Look at this now. I think this is a Lenovo laptop, right? This is a Lenovo laptop, and the input voltage is around 20 volts, all right? And then you have about 2.25 or 3.25 or 4.5 amps, which tells you that the charger, right? For instance, the charger that you need to charge this battery, this laptop battery, must be 20 volts charger, all right, and it must be able to give up to 4.5 amps. If that charger is giving 4.5 amps, all right, if you multiply the 4.5 times the 20 volts of that charger, you're going to get the power being delivered to this battery, which is going to be the power consumption of this battery. All right. So it's going to be the power consumption of this battery, all right, from the charger. All right, let me see if I can get another example. So all you have to do, if what you have is the current, just multiply it by the voltage. You are going to get the power. All right. Good. All right. So yeah, look at this. Look at this. This is a very nice one. So I don't know what device is this, all right? But this, all right, we work with 120 volts to around 230 volts, all right? And they tell you it's going to consume 2 amps of current, all right? So whenever you plug this device to power, all right, you have to measure the voltage that you are plugging it to. So if it's, let's say, 230 volts you are plugging it to, you multiply that 230 times 2, all right, that will give you 460 watts, which tells you that whenever this device is plugged, this device will consume up to 460 watt of power. All right, so that's how to know the power consumption of a solar. So let's say you happen to see an appliance that don't have maybe the label, and there's no way you could ascertain what the power consumption is. If you know the model, all right, if you know the model, for instance, iSense TV, all right, iSense Smart TV, all right, 43 inches, all right, power consumption. All right, you could just Google that, and you might be lucky to find. Yeah, you might be lucky to find a precise power consumption. All right, so I know that for 3 inch iSense Smart TV is actually 70. I think it's 70 watts. All right, because if you check, I've checked it already, so I know. So which means that with this value, all right, you are still safe. So if you use anywhere between 75 and 100, so usually you can just add 75 plus 100 and divide it by 2 so that you take the average. All right, that should give you around 80 something. All right, so which makes you also safe. All right, I'm just trying to tell you, ways that you can check the power consumption of a device. Another thing you could do is to use what we call AVS. All right, and this is a very smart way to do it. Can I get this device? Let's see. All right, cool. This is it. See if I can just get. Let me open this up. I don't like tape. Junior. Junior used to do rubbish. Okay, so this device, right? If you can lay your hands on this device, I think it's around, I don't know, maybe it should be 15,000 or so. So this device, right? If you can lay your hands upon, let's say you have an appliance that you don't even know the power consumption, right? You could easily get that device, plug this device into power, and connect that appliance to the output of this device for you to read the voltage and tell you the current consumption by that device. All right. So you can just multiply these two together and then it's going to give you the power consumption. So let's say you have a TV that or a fridge that you don't know the power consumption. Plug this to power, right? As you can see, this is connect this one to power supply and then plug the refrigerator to this output. All right. So it's going to record the voltage that is receiving and the current that the refrigerator is consuming. All right. So you can just multiply the two and you're going to have the power consumption of that. So here is actually around 11,000. So it's a little bit very. So you could use this device also to check the overall power consumption of a house. All right. Yes, you could use that. So what you can do is to plug this to the main DB or the changeover point where they connect the load. All right. So the NEPA power is going to enter here, and then their load is going to be connected to this place. So you're not going to ask them to turn on everything that they want to use with the system. So it's going to record the voltage and all the current that has been drawn by all the appliances that they put on. All right. So you can easily just multiply the two, and you're going to get the total power consumption for the whole house. You don't have to even go through, drawing the table that I showed us earlier. Does that make sense? So I'm just giving us a lot of ways we can get the power consumption of a device, and so on. All right. So having done that, right, let's go back to our table. Now the client has 10 bulbs, right? I mean, sorry, a 10-watt bulb, four of them, all right? And uh, you get the replay. All right. So I think I stopped sharing. Let me share the screen. All right, cool. Now, the table is just one way to know the total power consumption, right? I've showed us a lot of ways and all of that. All right, so for LED, all right, the person wants to put it on for 5 hours, all right. So firstly, this 10 watts, what you first have to understand is that this 10 watts, all right, means that my board is not showing yet. Let me just wait till it shows up so that we can follow up. Come on, come on, come on, come on, come on, come on, come on. We don't have time. Oh, okay. Yeah, I can see it already. I'm just waiting for it to load up. Okay, it's up now. You can see my screen now. All right. So let me even stop this one. All right. So this 10 watts, all right, means that the bulb is going to be consuming 10 watt of power in 1 hour. Please take note. It's going to be consuming what? 10 watt of power under 1 hour. All right. So if you put on this LED light now, after 1 hour, this LED light would have consumed 10 watts of power. Now he has four. It means that if you put on 4 LED, all right, after 1 hour, it would have consumed what? 40 watts. All right, it would have consumed 40 watts. It consumes 10 watts per hour, and you have four of it. All right, that means the four LED will consume what? 40 watts in 1 hour. Now it wants to have it wants to have um, the system on for 5 hours. All right, it wants it to be on for 5 hours, which means that after 5 hours, the 40 watts would have consumed 200 watts in total. All right, 10 watts of LED. All right, is using four. The four of them will consume 40 watts in 1 hour. Now, it wants to use it for 5 hours, which means that 40 times 5, at the end of 5 hours, you would have used what? 200 watts. All right. The refrigerator is 150 watts. He has one. He wants to run it for 8 hours. At the end of 8 hours, he would have consumed what? 1,200 watts. He has a laptop, one. He wants to run it for what? 4 hours. Which means at the end of 4 hours, he would have used what? 260 watts. All right, so what are the information you need from the clients? The appliances and the power consumption of each of the appliances and how many. And then ask him, how long do you want to use this appliance every day? All right, how long do you want to use it every day? Then he tells you, I want it to last for 4 hours. I want it to last for 5 hours. I want it to last for 8 hours. Yes. Okay, let's move on. So the first thing you want to now do after you have known the power consumption, the daily power consumption of the client, the first thing to do is to size what? The inverter that the person can use. Now you want to know the inverter that can run that amount of power safely every day. This person will be consuming this amount of power every day. All right? He's going to be using this amount of power every day. Now, you are going to be plugging this LED light, refrigerator, laptop, you are going to be plugging it to the inverter. All right, which means that let me get a pen to write. All right, which means that every hour, the inverter is going to be experiencing 10 plus 150 plus 65. All right, which is going to be 215. All right. All right, this is going to be 215. Is that 215? 160 plus 65. Sorry, 225. All right, so the inverter is going to be experiencing 225 watts of load on it every single hour. All right, please follow me closely. Now, you have to go and look for an inverter that can handle 225 watts of power per hour safely. All right, you can't get anything less. You must not get anything less. Anything less will damage the inverter. You have to be able to get an inverter that can handle what? 225 watts of power daily. Per hour. All right. So let's move on. Now, what about this detail that you have right here? What about this 1,660 watts per day? It means that the client is going to be using 1,660 watts of power per day. Where is he going to be getting the power from? Definitely from the battery. All right? Definitely from the battery. Now, what that means is that you have to get a battery that can deliver 1,660 watts of energy every day. All right? And that will also determine the solar panel that you're going to get. The solar panel that you're going to get must be able to deliver 1,660 watts of charge to the battery. Because if the solar panel does power, the battery will not have that power to deliver. Right? So you have to deliver 1,660 watt of panel every day going to the battery so that the battery can now give the client daily. I hope I'm making sense. Are we following? All right. So now, how do we determine the proper size of the inverter that we need to buy? There are quite to consider. All right. Size to cover the continuous sum of simultaneous load plus 20, 25 to 35% safety margin. Now remember, the load that will be on the inverter per hour is 225. But you can't just say, let me go and buy 225 watt of inverter. What if the client's mistake 5 watt of power to it? That means it's going to damage the inverter just by a simple mistake. No. Which means that you have to increase the power of the inverter by exactly 225. All right? You have to increase it by a margin between 25 to 30%. So you have to add between 25% of that 225 to 30% of that 225 watts to the 225 in order for you to get the proper size for the inverter. All right? Now, take note of that. Another thing you have to take note of is that you have an inductive load in the load that the client wants to use, and the inductive load is the refrigerator. One thing about the inductive load is that when you put them on initially, they tend to spike, which means that if the refrigerator is rated 150 watts, it can surge up to 4 times, 3 times its rated capacity. So in our table, all right, in our table, we have a 150 watt refrigerator, all right, included here, all right. By the time you turn on this refrigerator, it will not consume 150 watt. It will go up to, it can go up to 600 for some split seconds before it goes back to 150. What if you go to buy an inverter that cannot handle 600 watts? That means your refrigerator will just damage the inverter. All right, those are the things that you have to consider, which means that you have to get an inverter that can handle the surge rate of the refrigerator. So knowing fully well that the refrigerator can surge up to 4 times, its capacity, it means that you are not just going to go and get 225 watts inverter. All right, you have to now go get what 4 times. First, the 4 times the refrigerator size is 600 watts, which it first tells you that you can't get an inverter anything less than 600 watts. All right, come with me. Okay, so another thing you have to ensure is that you have to select a pure sine wave inverter to support sensitive modern electronic. What that means is that you have an inductive load, for instance. An inductive load cannot work well with square wave or modified square wave, like I taught us in the last class. You have to go and select a pure sine wave so that you have a smooth running, and there's no issue. All right. The last thing is that whatever the voltage of your inverter is, you have to match it to the battery. We are going to quickly share my screen, my notes. Sorry, my notes. Please still confirm you're with me. Let me, so that I don't miss anybody at any point. And if you have any question, please don't feel to ask immediately, please. All right. Are you guys with me? All right. All right. Thank you. Thank you. Okay. So now we said that the first thing inside the inverter is that you have to bump it up around 25 to 30%. Don't worry, my screen will come up. So let me just write the load that we have here. Remember, the load that is going to be on the inverter, all right? Load on the inverter is equals to 225 watts. So first step, increase that, increase by 25%. All right, which means that I have to multiply 225 times 1.25. All right, 1.25. So let me just quickly bring up my calculator and calculate this. Or you guys will see my screen once it's up. It's network that is causing that lag. I don't know why that. I think that latency is it's too much. That's too much of a time. I don't know why. If you remember, the load on the inverter is 225 watts, 25%. So this gives me. I think my screen is not showing again. Let me show. All right. So you bump it out by 25%. So and this will give us 281. All right, 281 watts. All right. The second thing is to the the um, the inductive load that is present, all right, can surge up to 3 to 4 times, all right. So the inductive load is around 150 watts, right? So it means that you have to buy an inverter that has a surge rating of around 3x to 4x its size, all right. Um, Now, so usually, if you go to buy an inverter in the market, they tell you the surge power, right? Which means that if anything surge, right, it can most inverter in the market has times two of the rated capacity, all right, to surge, right? So which means that if you go to buy a 4 kilowatt inverter, for instance, the surge rate is going to be around 2x, which means that the the inverter can actually handle 8 kilowatts for split seconds. That's what it means. All right. Even though it's rated 4,000 watts inverter, right, it should be able to handle 2x, all right, its capacity, which means that it should be able to handle up to 8 kilowatts of its capacity. All right. So, according to what we have here, according to what we have here, the after we increase the inverter, we are getting 281, watts. So if you go to buy 281 watts of inverter in the market, right, this should have about 2x, all right? Should have 2x surge rate, all right? 2x um, surge rate. Can anybody hear me now? one is good now. Let me share my screen again. Okay, so somebody's asking how where the 1.25 came from. The 1.25 is the 25% that I talked about just here. All right, it's the 25% that I talked about. Okay, uh, this 25%. 25% is the same thing as 1.25, right? So let's actually do that. So 25 over 100. All right. Let's just say 25 over 100 of 225. All right. So we're later going to add it to 225, but let's just do that first. So 25 year 4. All right. So which means 225 divided by 4. 225 divided by 4. That's 56.25. So let's add this back to 225. All right. Because we are adding 25% to 225. I hope that makes sense. So yeah, we arrived at 281.25, right? Which is exactly what we got here when we multiply this. Is that clear now? Please confirm you understand what I just did now. Is it clear now? It's breaking. It's not breaking from here though. Please, guys, you understand now? Okay, cool, cool. So let me just continue with that then. So um, so currently now, according to our calculation now, we need to get a 225. Sorry, I said 225. We need to get we have increased the inverter size that we have to get by 200 I mean by 1.25, which is 25%, and that gave us 281 watts. All right. Now, normally every inverter in the market must be inverter is 281. It means you can handle up to what 562. All right. Remember, the refrigerator is 150 watts. All right. So that means you have to get an inverter that can handle 4 times 250, which is around 600. All right. So finally, to get the size of the inverter, you can as well, all right, you can as well um, include the efficiency because inverters are not 100% efficient. All right. So most inverters you're going to get in the market are 80% efficient. So you want to increase this by 20% also. All right, so let me just write that. Let me just write that out. Um, include or increase. Sorry, increase by 20% efficiency. All right, efficiency. So which means you have to now increase this 562 times 1.2. All right, which is the 20%. All right, so let's quickly do that. Sorry, it's not 562. Sorry, damn, 562 is a mistake. 562 is the such this thing. The real thing is the 281, right? 281. Right. So here we're now adding 281. Um, I hope I'm not confused. Times 1.2. So that gives us a final inverter size of around 37 watts, right? 300. So let's go back to, please take note, 337 watts of inverter, that's the size, right? So let's go back to our slide. I just want to wait for the slide to come up so that we can. How come 1.2? Okay, 1.2 is we're increasing the inverter by additional 20%, all right, because of the efficiency of most inverters, right? The efficiency, the most inverters, okay, sorry, most inverters are not 100% efficient. In fact, all inverters, right? So after we increase it by the 25%, we also have to now increase that result by another 20% to adjust for the efficiency, if that makes sense, right? So two-step of increment. The first one is the 25%. The second one is the what? Is the 20%. So you have to increase it, twice like that in order for you to, get a proper size for the inverter, all right? So that's why we had to add the 1.2. So the first one we multiplied by 1.25. The second one we multiplied by 1.20. All right, just for us to get the proper size for the inverter. Does that make sense now? Please confirm you understand that before I move forward. Okay, clear now. Thank you. All right. So now remember, let me write the total this thing here. This one is 225. All right. This one is 225, which is the total load, right, that is going to be on the inverter per hour, right? This is the total load that is going to be on the inverter per day, right? But this is what we use to calculate for the size of the inverter, not this. This is what we use to calculate for the size of the battery that we will need, right? Because this is the amount of power that the customer can consume every day. So the battery we are getting must be able to handle this amount of power every day. The panel we're also going to get must be able to deliver this amount of charge to the battery so that it can give the customer daily. All right? Does that make sense? All right. So we use this for the calculation of the inverter, which is individual appliances. Oh, guys. Oh my God. We made a mistake. Oh, guys. We made a mistake. We're actually supposed to use, we're supposed to have another. Let me see if I can get another column here. All right, so it's not so much of a big deal, all right? The only difference is that I'm supposed to use, after we multiply this, right? Before, there's supposed to be another table here, right? So we're supposed to just add everything after this place, right? To use to calculate for our inverter size, right? So I can't actually include the table here. That's very painful. Okay, can't actually add the table here, right? But this there was supposed to be a column here. That's a mistake on my side. There was supposed to be a column here where 10 times 4 gives you 40, 150 times 1 gives you 150, 65 times 1 gives you 65, and then you're supposed to add all of those together, right, to get a particular value here. All right, that's the value we're actually supposed to use to calculate for the inverter size. I was thinking, I've forgotten that we have four bulbs here. All right, but of course we get the idea already, right? So um, yeah, you get the idea already. So these are the loads that is going to be on the inverter every hour, right? Four bulbs, one refrigerator, one laptop, and so forth. So if you add this, if you include this, it's just going to be 30 plus 225, right? So now assignment for everybody. Thank God I made a mistake. Assignment for everybody. The mistake I made now, let's go and correct it, right? So I'm going to include this. I'm going to change this to 2, right? And I'm going to change this to 3. All right. So now in your assignment, you're going to create an extra column here. All right. You're going to call that column. Let me just type it here. You're going to call that column um, total power. All right. You're going to call that column total power. All right. So how you do it is that you multiply this power times the quantity, and then you write the value here. All right. 150 times the quantity, you write the value here. 65 times 3, you write the value here. So you add that value, all right, and you're going to use that value to calculate the inverter size. Do you understand? Please confirm you understand my assignment. Confirm you understand my assignment, please. Let me do a last screenshot and just so that. All right. So yeah, so that's how to calculate the inverter size. All right. Now let's quickly do how to calculate for the battery, and then would call it a night. Tomorrow we're going to do solar panel sizing, and yeah, once we do solar panel sizing, I mean you are good, right? You are good. The remaining, discussion are just theories on some of the do's and don'ts that we have to understand, and then the last one is going to be how to mount panels on the roof. So there, I think I've done the video already, so I'm just going to do a voiceover on it to show you number one how to step on roof, right? Not just matching roof anyhow before you go and damage people's roof, right? And number two, how to really mount panels they calculate for the battery size, right? So this is literally the kilowatts of the battery that you want to get. I stopped sharing. Uh, let me just. All right, good, 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 good. Where's my screen again? Okay, I can't actually see. Let me just share my task. Okay. Okay. Is there sound now? All right. Yeah, there's sound. Share my screen again. I believe you can hear me, right? All right. So I was saying, please confirm the sound. All right. So I was saying that we don't just throw in the battery, the daily system requirement, which is 160, I mean 1,660 watts. You don't just carry it and go and use directly, right? What if the client decides to, oh, okay, please fix. Okay, don't worry, my screen will come up too. So what if the client decides to go above what you guys agreed a little bit? You know, clients can be falling. See, whatever you're doing in solar design and installation, you have to be very careful, right? You can't be having back and forth, arguments with clients after they have paid 10 million, 5 million to do installation, and they are not satisfied. Don't be on that side at all right? What you have to do is always be on the safe side. All right. Now, even though the according to our calculation, the client's consumption per day is 1,660, right? If you're wise, increase that 1,660 a little bit so that you go and buy the battery of that size. So that if at all they now decide to increase their usage later, they will still meet the battery there. All right. So always exceed their expectation. All right, that's how the client will be happy. If the client tell you, I want to use this thing for 4 hours, all right, in your budget like 4 hours, 30 minutes, or 5 hours, and tell them it's going to is 5 hours. I mean, it's 4 hours, sorry. All right, Ehen. That's how you're going to be safe. Oh. So, even though, okay, I think I'm audible back. Actually, having two challenges, network and the mic. I really cannot tell what exactly is wrong with the mic. Okay. Um, Let me share my screen again. So I was saying that you have to be safe, whatever it is. All right. Just hope my network is okay. All right. Even though the battery, all right, that we wanted, according to our calculation, is 1,660, right? Ensure you buy one. All right. Okay. Please confirm you can hear me now. I was saying that even though the battery size we calculated is 1,660 that we're going to use, you have to find a way to increase that, right? So that is why here, total daily energy for inverter efficiency, which is why what's wrong with my network code. All right, so I was saying that um, you have to divide that daily energy consumption by 0.8, all right? And after that, you have to multiply it by days of autonomy. Days of autonomy means that for instance, if you are I think I have to shut it down this night. Okay. Let's see if we can still push through. I don't know. Just of the network is. So you want to um, you want the battery to back up for 3 days, right? You want to charge in one single day, and you want it to last for 3 days. That's what days of autonomy means. It means that let's make for days when there will not be sunlight. You understand? So that's what the days of autonomy. So usually, you need it. You can just put one here, all right. But if the person has money and he wants you to do it in case of the days where there's not going to be sunlight, like rainy or cloudy days, right? You can just put days of autonomy 2, 3, 4, 5, 6, depending on So, but let's just put one here for now. So, yeah. So, and this is going to go back to 1844. All right. So, so another thing you have to now consider is you have to adjust for depth of discharge. I think I told us that I explained that to us already. So now I said for lead acid battery, they have a depth of discharge of 0.5, which means that you can't use more than 50% of their capacity. All right, you can't use more than 50% of their capacity. So you can't just buy one lead acid battery now and expect to get the maximum capacity from it. Right. So let me change this to 2. So let me go back to my slide and quickly explain, something very brief. I've explained it before. I just want to explain it again so we can we can understand it again. So I'm going to be sharing my notepad. Where's my notes? Sorry, share my time screen there. Let me wait for it to. All right, my screen is visible. So I just want to quickly explain to us um, the 50% depth of discharge, right? What it means. Now, for lead acid battery, I told us, right, that it has a 50% depth of discharge, right? For lithium ion batteries, they have 80% depth of discharge. What that means is that you can't discharge a lead acid battery more than 50% of its capacity. If you go beyond that, you're going to damage the battery on time. All right. So let's say I go to the market to buy a lead acid battery of 12 volts, 200 AH. What the 50% depth of discharge means, it means that I can't get more than 12 volts, all right, 100 AH from this battery, all right. That's what it means. Even though 200 AH is written, if I want to get 200 AH, I will damage that battery on time. If the battery is supposed to last for 3 years, for instance, it might not last up to a year. But for the battery to last well, durable, I can't discharge more than 50% of its capacity, if that makes sense to us. All right. So now, if I say what I need, the size of battery I need is this, according to the load that I want to use with it. It means that I can't just buy this. I have to buy two of this so I can get one capacity from it. So let's convert this battery to its power capacity. Remember, power is what? Voltage times current, which means I have to multiply what? The current, which is 200, times 12. All right, that should give us 200 times 12, 2,400 watts. All right, so this is 2,400 watts hour. So that's the energy I can get from this battery, but I can't get 2,400 watts. I can only get half of it. Why? Because of 50% DOD. all right? So which will give me 1,200 watt hour. That's the maximum power I can get from this. That's the power I can use safely without damaging the battery. All right. So if according to my calculation, I need 2,400 watts, that means I have to buy two of this battery to get what? 2,400 watts. Let me know if that is clear so I can move on. I just want to finish the battery part before we call it a day tonight. Is it clear? Is it clear? Please, guys, let me know if it's clear. All right, cool, cool. Thank you. So let me just. Right. I should come again. Oh my God. All right, I'll do that. I'll do that. All right, let me come again. Now, I'm saying that if you have a lead acid battery, all right, now this is a lead acid battery. So, let me show my screen. All right, so let me continue. So, this is a lead acid battery, all right, lead acid battery. And the battery is rated 12 volts, 200 Ah, all right? 200 Ah is the capacity of that battery, all right, which is the maximum current that can be drawn from that current in under 1 hour. All right. I'm saying that you can't use up to that 200 Ah. You can only use 50% of it safely. And the 50% of the 200 Ah is what? Is going to be 100 Ah. So if according to my need or the need of my client, the person needs 200 Ah, it means that I have to buy two of these. Because if you only get exactly 200 AH, you will only be able to get 100 AH from that 200 AH exactly. But if I buy two, two will give me 400 AH. But in reality, I'll be able to get 200 AH from that two battery. Why? Because lead acid battery can only discharge safely 50% of their capacity. They have a depth of discharge of 50%. What that means is that don't discharge them below the 50% of their capacity if you want them to last you. All right. So now, if you calculate this in terms of power, now we can get the power of this battery simply by multiplying the current, all right, by the voltage, which is what we did here. All right. And by the time we multiply 200 times 12, we had 2,400 watt hour. All right. And this 2,400 watt hour is the 200 times 12. Remember, we can't use 2,400 watt hour. We can only use half of it. And half of it is what? 1,200 watt hour. Does that make sense now? Do you understand now? All right. Let me know if you understand now. All right, cool. Thank you. So let's quickly move on. Let me just the battery and then we'll call it a night. I mean, we've tried this night already. Okay. So now, uh, after we've understand that, I was trying to explain the depth of discharge. All right. Let me screenshot this to us in case we might need it. All right. So, all right. So I've sent it in the group chat. If you need the full material is up for sale. Right. So I can't give us that for free. All right, that's my intellectual property. Please, guys, I beg. I beg. So yeah, if you need all the materials, right, they are for sale, right? So yeah, that's it. Okay, so now we have increased the daily energy need by 1,660. We've increased it by 20%, and now we are using 1 day autonomy. And now we can't just go out and confirm our stay online. 3688. Yeah, let me share the screen again. Uh, all right. So this is why we are using this 0.5. Okay, this is why we're using this 0.5. Why? Because if you just go to buy this size of battery in the market, we will not get the best. So we have to increase it by, like I explained us to us in that right. We have to increase it by 0.5. So after you do that, you are actually going to buy is 3,688 watt hour. So if you compare this to your load, right? This is the requirement, daily requirement for the client. All right. This is the daily requirement by the client. All right. After we go through our calculation, we find out that actually we are going to need what? This as a battery. Right? So how do you convert this back to the normal rating of your batteries that batteries are rated, right? So how you can do that is to now to your inverter size. Remember our inverter size. Did you finish our inverter size? I've removed it too. I think we had around 600 watts for our inverter, right? You can't get 600 watts inverter in the market, so we can buy 1 kV inverter, which is 1,000 watts inverter. All right, so you can buy 1,000 watts inverter. So the 1,000 watt inverter is a 12 volts rated inverter. All right, is 12 volt rated. So what you just have to do is to divide this value by 12, which is the size of the inverter. I mean the voltage of the inverter. So if you divide this by 12, you are going to get the um, so I'm going to divide this by 12, right? So whatever it is that you're going to divide your battery with is going to be the size of the inverter that you want to use, because you have to get the exercise that matches up you have to get the voltage that matches up with your inverter, right? You can't can't connect a 12 volt inverter to a 24 volt battery. You're going to damage that inverter, right? So if your inverter is around 1 kilowatts, it's most likely going to be a 12 volt inverter. So you have to go and get a 12 volt battery. If your inverter is around 2 kilowatts, it might be a 24 volt inverter. So you have to go get a 24 volt battery, right? We're still going to see how to do all of those maybe tomorrow or so, right? So, but for now, let's just focus on this, right? So our inverter size is going to be 12 volt because it's 1,000 watt inverter, right? So you guys understand how I arrived at 1,000 watt already. What we calculated actually was 600 watts, right? But you can't get 600 watts inverter in the market, so you have to just buy 1,000 watts, all right? And so now, if you divide our value here, which is 3688, all right, let me write this again. 3688, all right, divided by 12, that gives you around 307 H, all right, 307 H. So the battery you have to go buy is going to be a 12 volt battery, all right, 307 AH. All right. But you can't get a 12 volt battery 307 AH. What you can get is 220, 230, I think 240 at max, right, for lead acid. All right. So you have to find a way to divide this maybe into two. Maybe you now go and buy um, All right, please confirm you can see my screen. It's still blank. Okay, confirm you can see my screen now. So you have 300 and I think it's 307 now. Yes, 307. So the battery that, according to our calculation, we got a battery of 12 volts, 307. All right. All right, but we can't get 307 AH in the market, so we have to maybe buy 12 volts, 200 AH. All right, two of it. You're going to buy two of it. All right, so that by the time you add 200 plus 200, you get 400. That gives you more, even more current, right? So that's one way you can do it. All right. In fact, that's one way you can do it, or maybe the only way you can even do it. Safe. The only way you can, go about this is to maybe buy a lithium-ion battery. If you're buying a lithium-ion battery, you don't have to go through this process, right? You just have to go back to your the watt calculation. All right, 88. I mean 3,688 watt hour. So just go and buy a 4 kilowatts lithium-ion battery in the market. That's if you see Sha. I think it's 3.55 that you are. So maybe you most likely are going to buy a 5 kilowatt lithium ion battery. All right. So that way you don't have to split the battery into two and that kind of stuff. So I hope you understand. Please, we have spent so much time already. If you have any question, right, regarding everything that we have done, right, um, put your question in the group chat, please. All right. Put your I need to get going right now. So put your question on the group chat, right? Any question that you have that is not clear, right? Put your question on the group chat, and I'll answer it right there. All right. So thank you so much again for tonight. Uh, I'll see us tomorrow by God's grace. Please take care and have a good night. Thank you.